Cloud service provider. With cloud services, the infrastructure, physical hardware is taken care of by the cloud vendor. Your resources are virtualized and you can access them through the internet. You determine when and how often you need them. So your interaction are customized to fit your business needs. This adds elasticity to your business. Servers located at a physical location on premises. In traditional on premises environments, you figure out how much capacity you need, purchase the hardware, wait for it, set it up, and access the resources over your network. The challenge with on premises environment is if there is not enough capacity, you must purchase more and wait for the service to be delivered to the site. Another challenge is if you have too much capacity, you are left over with an over provision environment. Over provision environment. Cloud service provider. With cloud services, the infrastructure, physical hardware is taken care of by the cloud provider vendor. Your resources are virtualized and you can access them through the internet. You determine when and how often you need them. So your interaction are customized to fit your business needs. This adds elasticity to your business. This is how it works. Amazon Web Services owns and maintains the network connected hardware. Interacting with AWS, you provision what you need. You can interact with AWS and manage your resources using AWS Management Console, the AWS Command Line Interface, or AWS SDKs. So three ways to manage the resources: AWS Management Console, the AWS Command Line Interface, and the AWS SDKs, meaning SDKs. So the command line is you go to the dashboard, you have all the elements, you can manually choose which one you need. The command line is you type the code and it automates the system. And the SDKs are software development kits. So you use those software to build, I guess, customized cloud solutions. The result of using the cloud solution is you have the control to customize your storage, business applications, and the configuration of your entire network. AWS Management Console demonstration. So this is the console demonstration, right?
Let's see what the AWS Management Console looks like. I will sign into the console. I will use I am user. We will touch on this topic later. Now, provide a password and sign into AWS. On the right-hand side you can see that I signed in as practice. And, in the drop-down menu here, you can see the number of AWS regions. Click Ohio. And now, whatever resources I decide to launch, these resources will be launched in AWS Ohio region. This is the main page of the AWS console. Now clicking on services, you can see all different service categories that are there on AWS, such as analytics, blockchain, compute services, containers, database services, Internet of Things, machine learning and such. Choose the service. Click on it and now you can start working with the service, configure the resource, launch it, manage it, and so on.
Which statement best describes traditional on-premises environments? You are responsible for purchasing hardware to match your capacity needs. That's true. You do not have to pay for any capacity storage that you don't use. That's not true. Servers come configured to meet your needs after you place order. No. With on-premises environment, you do not need to wait for their service. That's not false. But the first one. All right. What are the three key benefits of using cloud computing? So the three key benefits of using cloud computing are interesting. I think I made programmable resources, dynamic abilities, pay as you go. Three benefits: programmable resources, dynamic abilities, pay as you go. Okay, dynamic ability, pay as you go, programmable resources. Programmable resources. AWS categories of services. Analytics, application integration, AR and VR, blockchain, business application, compute, game tech, end user computing, developer tool, database, customer engagement, cost management, Internet of Things, machine learning, management, governance, media services, migration and transfer, mobile, security, identity and compliance, networking and content delivery, satellite, robotics, storage. AWS categories of services icons. Okay, so in order to manage the cloud, AWS cloud, these five components, one should focus on these five components. These five components are the service area, are the main service area. So compute, right? Compute first, you do the storage, you do the databases, you do the networking, and then you do the security, right? So Amazon Route 53 user, virtual private cloud, Amazon EC2, Amazon Elastic Block Store, Amazon Simple Storage Service, Amazon DynamoDBs. So this one is a network, which is Amazon Route 53. Amazon Route 53 is a network. This is the user interacting with the VPS, virtual private cloud. Inside the virtual private cloud, you have Amazon EC2, meaning your server, and you have the storage, Amazon Elastic Block Store. Block Store. You got the Block Store. You also have the Amazon Simple Storage service that is here. And they also have Amazon DynamoDB, meaning databases. So these are the main components service area. So we have the network here. We have the storage. We have the databases. We have the compute, right? And we have, what else we have? So we have network, databases, storage, compute, and the security. The security should be, yeah. So this one is a security. Amazon Elastic Block Store. So Amazon Elastic Block Store allows you to create volume or virtual drives. The VPC cloud, virtual private cloud, that's the security. Okay, so five components are really important: compute, storage, databases, networking, and security. So these are the five pillars. I mean, the five foundational area to interact with AWS services: compute, storage, databases, networking, security. And we have Amazon Route 53. That's the network redirects the users or the domain name server, the domain the DNS. We have the virtual private cloud, which is security. We have Amazon C2, that's the compute, and we have storage. So the Amazon Elastic Block Store allows you to create storage, Amazon Simple Storage. We have Amazon DynamoDB. This is the databases. Okay. I think this is the core. I mean, this is the crust of the creme de la creme, right? Or the crust of the matter, the heart of the matter, right? So let's take this one. Understanding the AWS global infrastructure. In this lesson, you'll review common resources that are launched within the AWS global infrastructure. The AWS global infrastructure is made of several different components. To learn more, choose each number marker. So let me remember what I have learned from global infrastructure. So the global infrastructure involves the regions, right? Involves availability zones. That also involves edge locations. So these are three points that I remember about the Amazon global infrastructure. Okay. So we have data centers, we have AZ zone availability zones, we have AZ regions. So in a region there are availability zones, right? So in one region you can have different availability zones. So a region contains different types of availability zones. data center. So you have data centers. From the data centers, it extends. You create availability zones. And then you have regions. In the regions, you have different availability zones. Data centers. AWS resources are launched on the AWS global infrastructure, starting with the data center. This is where your hardware is located. It typically houses thousands of servers. Availability zone. Data centers are clustered into availability zones. Data centers are clustered into availability zones. Within each availability zone, there is at least one data center. So within each availability zone, there is at least one data center. Availability zones that are located in a specific geographical area form an AWS region. This means they have two or more availability zones in each geographical zone. Availability zones are designed for fault isolation, which protects the data centers from being affected as a whole, meaning if one availability zone goes down for a certain reason, it's very unlikely that other zones will go down for the same reason. So, all right, so here we have. So you have one data center per availability zone. And you can have 3 data centers in one availability zones. So in availability zone, you can have 2 or 3 data centers. Okay. And in one region, you have 2 or more availability zones. Understand that? Region. Most resources are region specific. An AWS region is a geographical area typically consisting of 2 or more availability zones. Communication between regions uses the AWS backbone network infrastructure. So a region can contain 2 or more availability zones. And in each availability zone, you can have 2 or more data centers. So within each availability zone, there's at least one data center. Okay, so this availability zone, it's at least one data center. Availability zones are located in a specific regional AWS region. This means they have 2 or more availability zones in each geographical area. Availability zone are designed for fault isolation, which protects the data centers from being affected as whole. When one availability zone goes down for a certain reason, very unlikely the others will. AWS Global Infrastructure, choose the following button to learn more about it. Now that we know what AWS Cloud and AWS Global Infrastructure look like, let's explore how these advantages can help your applications run as efficiently as possible. To learn more, expand each of the following 6 categories. Trade upfront costs for variable, increase speed and agility, move to global presence, start spending money running data mining essentials, testing for massive economy of scale. I think we have that. Which statement best describes an AWS data center? An AWS data center cannot house more than 100 servers. An AWS data center is where your hardware is located. Your hardware is located. It typically houses thousands of servers. An availability zone will consist of at least 100 AWS data centers are not designed to anticipate and tolerate failure. So an AWS data center is where your hardware is located. It typically houses thousands of servers. That's true. Okay, core service simple overview. Compute. Amazon Elastic Compute Cloud. Amazon Elastic Compute Cloud, EC2, provides scalable computing capacity in the Amazon Web Services cloud. In the compute area, there are various options for the types of resources you might want to launch, such as the following: virtual machines, containers, batch processing compute resources, serverless compute. So in the Amazon EC2, there are things that you can do. You can do virtual machines, create containers, batch processing compute resources, serverless compute. So the EC2 Amazon Elastic Compute Cloud EC2 provides scalable computing capacity in the Amazon Web Services Cloud. In the compute area, there are various options. The type of resources you might want to launch, such as the following. So for the EC2, provides the following service. So the ability to creating virtual machines, VMware virtual machines, containers, else batch processing compute resources, group processing compute resources, batch and group processing compute resources. Resources. Serverless compute, serverless compute, serverless compute. So we have serverless compute. In this case, for instance, Lambda, right? Lambda is a serverless compute environment. The Amazon EC2 one is the first core service we often discuss on AWS. Okay. Amazon EC2 benefits include the following: complete control of your computing resources, resizable compute capacity, reduce time required to obtain and boot new server instances. There are a broad variety of instance types, so you can pick one specific to what your workload needs. To learn more about Amazon EC2, expand each of the following categories. Amazon EC2. Amazon EC2 is a virtual machine launched on AWS hardware. AWS takes care of the hardware, whereas you focus on setting up Amazon EC2 to match your application needs. What you launch. The application you can launch on Amazon EC2 are similar to what you would do on a typical server: websites, databases, analytics, analytical application, and more. Flexibility and control, select and configure, start step, sizable, scale, instance type. There are many types of instances, each built to provide a specific set of resources, and they run on a certain hardware, including Intel families in Graviton. There are a broad variety of instance types so that you can do the following. Pick the most suitable type of virtual machine for a specific application. Match your needs as precisely as possible. What is Amazon EC2? Okay. Instance type details. According to instance type, determine your use case. General purpose, high performance, in-memory databases, machine learning, distributed file system. Memory optimized instances are helpful when focusing on memory. When the most critical resource is RAM, memory, you will choose instances from within his family. Open source databases, in-memory caches, and real-time big data analytics could be run on such instances. Accelerated computing instances are helpful when the focus is on the graphics processing unit. Accelerated computing instances are helpful when the focus is on the graphics processing unit. GPU. Running ML models, machine learning models, computational fluid dynamics, graphical workloads, or other workloads needing GPU are use cases for this instance type. Cloud architect. I like cloud architect. Sounds nice. Storage optimized instances are helpful, focusing on maximizing the number of transactions per second, TPS or IO intensive and business critical load. Storage optimized instances are helpful when focusing on maximizing the number of transactions per second or IT incentive critical. General purpose instances provide a balance of compute, memory, and networking resources and can be used for a variety of diverse workloads. These instances are ideal for applications that use these resources in equal portions, such as web servers and code repositories. So, to determine what type of instance you need, we need to know what kind of application you want to run. So, suppose you have a website or an application, it's probably doesn't require a lot of resource. So in this case, we can use a general purpose instance, right? Which gonna give you a balance of compute, storage, networking, and security. Okay. If you have a gaming, it has to be compute optimized. Okay. Storage optimized, memory optimized. So we have general purpose, memory optimized, storage optimized, compute optimized, accelerated computing. accelerated computing. Okay. And we have so for the memory optimize. Uh, we have the following instances: R4, four, five, X1, Z1. Okay, this is instances in compute. So instances we have instance. Okay. Good. So let's see. In the case of accelerated computing, we have example F1, G3, G4, P2, P3 instances. Okay. Storage optimize. Storage optimize. So we have V2, H1, I2. Instances, okay. General purpose instances, or general purpose. We have A1, M4, M5, T2, and T3. These are instances. Compute optimize. Compute optimize. Compute optimize. Okay, C4, C5. Use case network intensive workloads. High performance file system. High compute and memory intensive. Machine learning and high performance computing. Maximize the number of transactions processed per second. Okay. Use case. Storage optimize. All transaction workloads. Batch processing. Yeah. No. Compute optimize. Network intensive. Large internet. HPC optimize. HPC services. HPC 6. It's the chip. HPC 6. Best price performance for running HPC workloads. Serverless compute.
Let's now see how it looks like to create a Lambda function. I am in AWS Lambda console and now we click Create Function. I will offer my function from scratch. We'll give it a function name, in this case my test Lambda. So select the runtime. You can see there are multiple runtime options supported. I will stick to the one by default. Click Create Function and now I can start working with it. I scroll down and you see I have the code source. What I can do is, I can import code from a zip file or from the S3 location. I will make a little modification here, say, hello from Olga, deploy, and then test it. This is what the response of this Lambda function looks like when we trigger it. As you can see, this only run for 2.35 milliseconds.